Hi, as you know, we're starting our new unit and we're going to begin with waves. And to begin with, we're going to learn some new words that we'll be using throughout the unit. The first word everybody should know, because we've already learned that, and it is matter. And we know that matter is anything that has mass and volume. The second word we've used, and we'll be using it a lot more, but we haven't really defined it, and it is energy. So the definition we're going to use for energy is the ability to create a change, as in temperature or movement. So think about it for a minute. For energy, what do? We eat for energy so that we can move more. Think about the atoms, the structure of atoms in a solid, how they're all packed together real tight, they can only vibrate. And then when they get warmer, like ice gets warmer, then it starts to melt and the particles move a little further apart. They can move around. And as it gets even warmer, they move around real fast. In fact, they leave the liquid and become a gas. So heat energy is changing the solid ice to a liquid and to a gas. Our next term is the law of conservation of energy. And what that means is we can't create energy, we can't destroy energy. Energy can only be transformed from one form to another. It never vanishes, it never goes away. Wave. I know that everybody has seen waves at the beach. And think about a wave at the beach when you're past the break line. You're deeper than the break line. And the waves are kind of rolling like this, like a swell. Well, that's a classic picture of a wave when we're talking about waves in science. When we're talking about radio waves, microwaves, that's a classic formation. Now, a wave is simply a way for energy to move from one place to another place. A wave is a way for energy to move from here to there, one place to another. It travels as a wave. Everybody knows this next word, echo. Echo is a reflected sound wave, and we'll be talking about sound in this unit as well. Okay, speaking of sound, that's our next word. And sound is basically a disturbance, and it travels through a material as a wave. What happens though with sound though, traveling through material as a wave, it pushes the particles closer together and then further apart, and closer together and further apart. So when we draw a diagram of a sound wave, you'll see waves real close together and then waves further apart, because that's what sound does, pushes the particles closer together and then further apart. Now, amplitude, if you are in the band or you're really into music and you're really into stereos, you may have seen people talk about amps. How many amps does the stereo put out? Well, they're talking about amplitude. And amplitude is the height of the wave, and it translates to loudness when we're talking about music. Frequency is the number of complete wave cycles, crest to crest, that pass each second. So it's the number of complete wave cycles that pass each second. And it translates to pitch when dealing with music, higher pitch, lower pitch. Frequency deals with pitch. It's how fast the wave is moving, how many complete cycles of a wave pass in 1 second. Wavelength is simply the distance between two waves. We measure that by measuring crest to crest, which is the highest point of the wave. So wavelength is crest to crest. We could also measure it trough to trough to measure wavelength. Okay, here's a diagram of a wave, and a lot of these terms or properties of waves are on this diagram. First of all, here's our wave in black. That's our wave. This black line going through the middle of these waves is imaginary. Okay, it's not really there. It's there for us to see the midline of the wave. Now, if we look at wavelength, which we just talked about, we said it was the distance between a wave, complete cycle of a wave, and the distance between wave cycles. We can measure it crest to crest. And then if you look here, the crest is the highest part of the wave. The crest is the highest part of the wave.
Let's see, I'm ready to go.
Trough is the lowest part of the wave. So we can actually measure wavelength crest to crest or trough to trough. Crest to crest, trough to trough. Now we talked about amplitude and we said that was the height of the wave. If we have a midline going through a wave, then our amplitude can be from the midline to the crest, or it can be from the midline to the trough, because those distances, those heights or distances should be the same. And remember, in music, amplitude has to do with loudness. Troughs, we already said, is the lowest part of the wave. And here I've drawn one complete cycle. It goes from trough to trough. We could also say that there's one complete cycle going from crest to crest. Now these have to do with the properties of waves. Wave is the definition of it. Amplitude, frequency, wavelength, those are all properties of waves. And we'll be learning more about this as we go through our unit.